In this research, we are going to dissect internet traffic on port 0. Now you might wonder why port 0. Well, in some protocols like TCP, UDP, UDP Lite, and SCTP, using port number 0 is not allowed. However, we see 76 GB of traffic using port 0 and these protocols in 1 week of IXP data. Well, of course, there has been some studies on port 0 traffic, but both of the previous studies used darknets as data sources. Now, in this work, we use traffic from a large European IXP. This has two benefits. First of all, at the IXP, we see real traffic instead of just scanning artifacts from darknets. And we can see bidirectional flows, which makes bidirectional analysis possible. And also in this work, we add active measurements to identify servers. Our data consists of 1 week of IPFix flow data, which contains 31 terabytes of traffic. And also in this presentation, whenever I say port 0 traffic, I mean flows from the first week of September 2019, where either source port or destination port is 0 and their protocol is equal to either UDP, TCP, UDP Lite, or SCTP. Out of 31 terabytes of data, we observed that 76 gigabytes of the data were port 0 traffic, and more than 99% of this traffic, this port 0 traffic, had source and destination port set to 0 and was one directional, and also used UDP in IPv4 and TCP in IPv6. We also observed that more than 16% of the source IP addresses in IPv4 were servers. Well, they were also observed in bidirectional flows. That means that it might be their answer to port 0 traffic, and it might be that they are not originating the port 0 traffic, but actually that means that they weren't filtering port 0 traffic. In IPv6, we didn't see any of those servers. Now let's see how port 0 traffic really looks like. Here you see the EAS distribution for both IPv4 in red and IPv6 in blue for port 0 traffic. You see that EAS distribution for IPv6 is much more concentrated. We have more than 6,000 EASs for general IPv6 data, but in IPv6 port 0 traffic, we see less than 100 EASs involved. Also in the IPv4, we see that 50% of the traffic comes from 111 EASs and goes to 33 EASs. And in IPv6, we see that 90% of the traffic originates from 3 EASs and goes to 3 EASs. Now let's dive deeper into the EAS distribution. Here in the plots, we have the top 10 source destination EASs. And in IPv4, we see that more than 6% of the traffic comes from only one EAS and goes mostly to one EAS. And in IPv4, we see that more than 70% of the traffic is coming from one EAS, and more than 80% of the traffic is going to one EAS. So you see that a large share of the port 0 traffic is caused by a small number of EASs in both IPv4 and IPv6. We also analyze packet size distribution, both in IPv4 in solid line and IPv6 in dashed line. In IPv4, the packet size distribution is much more distributed or unstable. In IPv6, we see that all the packets are really smaller than 102 bytes. And half of the packets are 78 bytes, so they're relatively small. And 12% of the IPv4 packets are only 60 bytes. So that means that we also have some small packets in port 0 traffic. And we also analyzed TCP control flags in IPv6 traffic. We saw that 90% of the traffic in IPv6, which used TCP, had only ACK bits set, and less than 10% of them had only reset flag set. And that might be the normal answer to an unpredicted packet in TCP. And I checked them, and they were mostly response to these ACKs. So that's irrational. And also we had a very small percentage of the packets with no flag set. So to conclude, we observed that we had a lot of port 0 traffic in the internet, and mostly these port 0 traffic were one directional, and they were mostly UDP in IPv4 and TCP in IPv6. Also, we observed that IPv6 packets are relatively small and they might be suspicious and maybe more interesting to study more. And also, a small number of ASs contribute to a large share of port 0 traffic. For future, we want to analyze longer time spans of IXP data, and we want to also have an active measurements on port 0 traffic to see how different networks filter port 0 traffic. Thank you very much for your attention.